this video is going to be about backpropagation. Now that we have all of the maths that we need, we're finally dealing into some real neural network stuff. So for people that don't know what backpropagation is an algorithm that is basically used to tweak the parameters of a neural net, and it's basically how a neural net is gonna learn. Okay, so let's look at this example for backpropagation. Okay, so for this I'm gonna go back to our fellow Newton, and we're gonna go back to the second law of motion, obviously. So you remember this, right? Look at the screen over here. So F is ma. This is where all of our shenanigans began. So we said m was a 3, a was a 10, right? And then what would be the units for these guys? Mass would be measured in kilograms, and acceleration would be measured in meter per second square. Now, why is acceleration a meter per second square? Because acceleration is basically change in velocity. So let's encode it that way instead. So instead of saying a is a 10, I would say a is velocity by time taken. Okay. So what is velocity? Velocity is basically distance by time taken. So we could do it this way. And then I would assign all of my variables. So s, which is the distance, let's say it's 10, t for time, which is, let's say, 1. So distance will be measured in meters and time would be measured in seconds. Okay, so we have this now. Okay, and the reason we're doing this is because we want to understand backpropagation. Okay, so let's look at all of these equations, and then let's look at it a bit differently, okay, by using a graph. So for that, we are going to go over here, and here's what we're going to do. F is the thing that I want to find. Okay, so before all of this, let's actually execute this code right over here, yeah, let's see what F is going to be. So F is going to be 30. Okay, so let's look at why that F became a 30. So force, how do you obtain force? Force is a multiplication of mass and acceleration. Pretty simple. Acceleration is basically a divide between the velocity and the time taken. Pretty simple. Velocity is again a division of distance over time. Okay, that's also very simple. So let me put it this way now. Yeah, let's use this color over here. So I represent all of that, and I'm gonna represent my nodes using blue. So over here, there you go, this and this. Okay, so now let's look at what just happened over here. Okay, so for this, in this particular figure, we're gonna go all the way downstairs, because that's the first thing that happens. If you look at the code over here, first thing that happens is we calculate the velocity. Okay, so for that you need to divide s by t. Okay, what is our s? Our s is basically what now? 10, right? So this guy is a 10, this guy is a 1. When you divide 10 by 1, you get a 10. So that would be the value for your velocity. Okay, so your time is again a 1, so your acceleration is also going to be a 10, right? And what about your mass? We know it is 3. So 3 multiplied by 10 will give you 30. So that's how you obtain your force, 30. Okay, now comes the most important part about backpropagation. Okay, so the way you do backpropagation is, now that you know what that F value is, you are gonna look back. Okay, so over here, that would be looking down at the 3. Okay, so when you look down at the 3 and you are trying to understand how did you get that value 30, okay, what are the variables that affect this value of force? And we already know how to find out how variables affect the output, and that is partial derivatives. Okay, so let's figure that out. Okay, let's figure out derivatives. So over here, if I want to know how my F is being affected, okay, so how is F affecting F? That is basically, okay, now I am going to use a different notation to say that. So I'm going to say, how is my F being affected by my F. Okay, so you remember how this formula came about, right? This is basically change in Y with respect to X, right? And so over here we have change in Y being the same thing as the change in X, so you just get this as a 1. Okay, so that's how force would affect the output of force. It's basically 1, which means whatever the force is, that is going to be the output. Now let's look at how force is being affected by mass. Okay, that's pretty simple as well. We already did this before. This is simple partial derivative. So basically what I want to know is, how is my force being affected by my mass? And the way you would do this is you would keep your acceleration constant, right? And then you are able to figure out limit as h tends to a 0, the function of m plus h minus the function of m divided by h. Okay, I'm not going to do that because we already know the answer is going to be a. Okay, a meaning the acceleration. So whatever the value of acceleration is, that is how your mass will affect your force. You could do the same thing over here for your how your force is being affected by acceleration. Okay, so I'm going a bit faster over here because we have already covered all of this in our previous videos, right? So we already know what a partial derivative is and why I am reading this as how force is being affected by acceleration. And so you can compute that, you'd get m. Okay, so whatever the value of m is, that is how your force is being affected by acceleration. Okay, and now here's the most important thing about backpropagation. Okay, so we know how force is being affected by acceleration now, right? Now we want to know how your force will be affected by velocity. Okay, and force and velocity don't have a direct relationship, but you know how acceleration will affect your force, right? You know how your velocity will affect your acceleration, so there should be a direct relationship from your velocity to force. So this we already did it before, right? And this was known as the chain rule. So I'm just gonna wave my hands all over it. You can watch the chain rule video if you want to know why. And the way you would find how your force is being affected by your velocity is very, very simple. The way you do that is you find out, because you already know how your force is being affected by your acceleration, right? So you put that term in, so how your force is being affected by acceleration, right? You multiply it with how your acceleration is being affected by velocity. Okay, so that is basically dA by dV. Okay, you can actually look at this mathematically, right? Again, you remember the way we calculated this notation right over here is basically change in y with respect to change in x, which is change in y divided by change in x, right? So that basically means that normal mathematics can be applied over here, and this is basically the way it works is dA and dA cancel out to become a 1, and what you get is dF by dV. Okay, so instead of cancelling it out by 1, it's actually more convenient for us to have it in these two terms. So that's how we are gonna do it. Okay, so we have these two terms now. Okay, great. I am not gonna calculate what this or this is gonna be, okay, for now. So let's just leave it at that for how force is being affected by velocity. We can do the same thing for time now. Okay, and we can say how force is being affected by time. Again, the reason we are doing this is because we want to know how each of the variables, right, like how turning each of the variables would put an effect to our output, which in this case is a force. Okay, so the way you would compute that is, again, you do a chain rule. Okay, so that would be how your force is being affected by acceleration, right, and how your acceleration is being affected by time. Okay, you could do that, because you know that you have that relationship, okay, because you already know what how your acceleration affects your force, right? And you have a direct relationship between how your time affects acceleration. So you can calculate this term over here, so you can calculate this thing easily. You already have this thing right over here, so that's also very easy. So good. So let's move on and let's see another variable, that is how your distance will affect your force. Okay, and over here now we have gone like three items deep. So you know how your S will affect you. Let me have an indicator there. So you know how your S will affect your V, you know how V will affect A, and you know how A will affect F. So therefore you should be able to derive how S is gonna affect F. Okay, this is all partial derivatives and we've already done that, and the way we are gonna link that is using the chain rule. Okay, so if you use the chain rule over here as well, it's also very simple. That is how your force will affect your velocity, right? How your force is being affected by velocity, and you know how your velocity will be affected by that distance. Okay, so if you look at this term over here, you have already computed this, and computing this over here is very easy because there is a direct relationship between velocity and distance. Okay, you could do the same thing again of how df is affected by dt. When you do that, what you'll see is df you know is being affected by dv, and you know how dv is being affected by dt. Okay, so good. So now we have all of this. Now here is something very important that you need to understand. Okay, and that is you have this term over here 2 times. Why is that? And that is because look at this thing over here. There is a t over here and there is another t over here, which means t will affect f, right? So this t, which is from acceleration, will also affect f, and this t from velocity will also affect your f. Okay, so that means both of these t are gonna affect f. Okay, and so the actual way, okay, so the actual way how you find out df by dt, so let's say this guy is our number 1, this guy is number 2, and the way you find out this df, actual df by dt, is really by computing df1 plus df plus by dt 2. Okay, so you add all of the terms, right, all of the df by dt's that you computed before. Okay, so this will be how you actually compute how df is being affected by how f is being affected by t. This right over here that we have just done, right, we have figured out how each of the variables is going to affect our output. That is backpropagation. Now what we should do over here is we should start coding this backpropagation, and that we'll do in another video. See you.